Okay, recording has started. Welcome to this week of Cloud Robotics Working Group. Almost forgot our name then. That's terrible. I say it so commonly. Today we've got a guest speaker. So Carter Schultz is here from AMP to talk to us about AMP's cloud challenges. Thanks for coming, Carter, and over to you.
Yeah, absolutely. I'll dive in. I've been working at AMP for I think around 8 years now. Originally as sort of the lead robotic software developer. For a while, I then ended up managing the robotic software group and now have the title of robotics architect, which is kind of made up, but lovely to do. And really, AMP is a company that's been trying to solve the general problem of recycling sortation. It started off solving that problem by deploying like an individual pick and place robot into existing recycling sorting facilities to replace human labor in those facilities. And so we deployed, roughly 300 of those robots around the world, and that was our big business for a while. And for the last few years, we've been shifting our focus from, selling this add-on to existing facilities that makes them slightly better to designing our own whole recycling facilities from scratch. The robots were written in ROS, starting in ROS, I think Kinetic at the time, and it's been about primarily C++ code base. And then as we've been doing our facilities, we've been moving up into writing control systems in Rust. So kind of a couple quick video clips here to give a sense of the scale. So on the left are the pick and place robots. For the standpoint of like a factory robot cell, they're pretty standard. It is, off-the-shelf commercial Delta ARM. We've worked with a couple different ARM manufacturers over the years. And then we are running a relatively heavy neural network on an onboard RGB camera that's doing the actual identification of the trash. So that was kind of the cornerstone technology that made AMP a successful company, was being able to deploy these large AI models at the edge at scale, couple them with off-the-shelf industrial equipment, and then make it all work in a pretty harsh environment. Like these recycling centers are dirty, gross, low maintenance facilities that are difficult to make technology reliable. Since the robotic business is very successful, shifting into the facilities, we actually use a lot less of the physical robots. It's a lot more airjet based sorting. So it's the same camera setup, it's the same software stack, but it is now more airjets than physical robots picking the trash. In terms of our like, hey, these things have to talk to the cloud and we have to deploy them and we have to do stuff, we are presented with two pretty different use cases now. The first one's when we're like deployed into customer sites, we have a customer provided internet connection. We are like hardwired in, so we do theoretically have 24/7 connection at a bandwidth that we have to like negotiate with the customer in our contract that you need to give us certain bandwidth. And so we want to be judicial about using that, but we should be always online and don't have a lot of the dedicated problems. But in the reality, the facilities can't provide us the internet connection that you would dream of or want for a system like this. And we had to work around a lot of the problems caused by how bad our customers' internet connections would be. Now that we're doing our own facilities, we want way richer data. We want more observability and ability to introspect and hop things on, but still we're paying for that internet connection. So we need to be relatively judicious with it. And we're doing a lot more of collecting data through the central facility control system and egressing it that way than necessarily having as much of the individual sortation cells exposed to the internet, though that still does happen. Just talking about what data we've been uplinking, the different data has very different needs around it, both from a customer standpoint and how you handle that data standpoint. The material that we actually saw with the camera passing under it was a product that we sold to our customers. Like part of what the installing one of these systems provides is introspection into how their own facility operates. And so that, is very high SLA data where we need to make sure that it is egressed. We need to make sure it's reliable. We need store and forward with it. It's not a very high bandwidth data, but it had to be extremely trusted. Then we care a lot about getting training data up for our machine learning team to get better stuff. So we have, very high resolution camera frames that are heavy, big, but we don't always need to get them off. It's okay to delay and send them later, but we want as much as we can and we want them well. Our log, we've actually never consistently uploaded. Our logs have always been a get on demand function on them. For most of our metrics and most of the like general things that we need going up, we started off recording them into ROS bags and uploading ROS bag files. I'll talk a little bit about this more. We eventually moved off the ROS bag format, but we also regularly have developers, hop on a system and record a ROS bag as a way to get observability into the system. Our systems have a few different kind of debug recording modes that we've built into them where we can turn on, very high resolution data recording for short bursts, specifically when we're trying to diagnose and reproduce issues. And so there's methods to trigger those and send them up. Lots of calibrations and configuration file kind of stuff that we need secured. That all got handled in yet another different system because the history tracking needed more on that. And then, as always, like we need people to be able to remotely access these systems. Having them be on internet connection and being able to remote into them has been extremely valuable. So like the user interface that we built for our customers to use is web page based so that we can just pull up that same web page when folks are remote. But that web page has pretty high data link requirements built into the back of it as it's going. So a lot of different systems got custom engineered at AMP to deal with these different types of data differently. And an enormous amount of engineering hours I wish we didn't have to spend went into dealing with these data pipelines in different ways. We did the ROS bags for a very long time. And then after we got to the scale of, a few hundred robots out there and robots constantly uploading, hundreds of kilobits of metrics data to the cloud, we realized it was actually getting incredibly expensive for us to run this cloud ingest tool that we had written that was opening the ROS bags, parsing through them, and then writing them into database tables to make them queryable and nice in various ways. And so our cloud team did a bunch of research on how we could bring that cost down and make the pipeline more efficient. And the solution that we settled on was, converting the file format of the uploaded metrics file to a Parquet file, which is directly indexable by BigQuery and much faster for cloud tools to natively parse. And so we took an open source project that I think was like ROSBag to Parquet, modified it for our needs a little bit now, and are now converting to writing Parquet files locally on disk and then uploading those. We also had to do a lot with, kind of custom store and forward behaviors, because part of that metrics data was that data we were selling to customers around the PICs. We had to write our own upload tool that would cache metrics to disk when internet wasn't available, when the internet connection was restored, prioritize sending up which traffic in which order, when the disk was full, prioritize deleting which data in which order. A lot of the logic around making sure that the data that you care about is retained, and when you do have bandwidth, uploading the correct data in the correct order and not flooding the network. All of that we wrote ourselves custom, and I hate that we had to do it, but really could not find the off-the-shelf options that were, free and open source and adaptable in the ways that we needed for those. For our configuration and calibration files, I don't love the solution that we ended up with, but it made sense at the time, and it's been hard to get off of, which is, these systems started out as ROS prototypes, which meant that developers were SSHing into them to do things. So we made our configuration files just like JSON files on the system, and we put them in Git repos. And still to this day, every single one of our robot systems that we deploy gets a Git repo in the cloud, and we have code using, library interaction with Git to, when configuration files are edited, commit those changes and push them. And when we have something like a failed update that we need to roll back on, we're like tagging commits in the configuration history with Git tags and then rolling back to specific tags, which all works. Like, it is a developer-ish friendly way of knowing configuration history and tracking of that over time. But again, a lot of custom tooling that we wrote to manage that, because just dealing with robotic configurations is quite hard. I will also say, like, absolutely hated Ross's system of like XML configuration in launch files and found that terrible. So started on the launch files, moved to then like command line arguments, moved to JSON files. We've been on JSON files with JSON schema definitions for a long time, but still just like config files are not a well-handled thing across robotics and cloud tools. I mentioned earlier, our logs are not automatically uploaded ever. All of our nodes have, runtime configurable logging and ways to turn logging levels on and off, but we only pull logs when a developer is specifically investigating a system. We view logs as a developer aid, and anything that we care to know about the system, we push that into the idea of metrics. And we actually want data going up as data to be indexed, to be queryable over time. I think a lot of people end up with these hybrid log systems where they're putting what should be metrics data into logs or vice versa, and then trying to scrape their logs. And we've fully circumvented that. Our system then, like we talk to external systems in a lot of ways. The main thing that we've done is, we've stood up just, a RESTful HTTP server on the system to provide, very structured endpoints that could be accessed by our cloud tools, and very structured endpoints that our customers could also integrate against. And, REST was a reasonable choice for that. And then we have a lot of unstructured kind of internal interaction using ROSBridge. So ROSBridge stands up a nice WebSocket that is both how our UI talks to the back end for any time someone's using a web page, and a lot of our other systems will just open up a ROSBridge connection to snoop on a ROS topic. We try to keep that to a minimum because it's hard when your system gets entangled with random ROS topics getting observed, but it is the useful thing until we build something more formal for it. Yeah, thing that I wanted to call out, like I talked to a lot of people about this along the way. I think we have easily 3+ years of developer time spent into building custom cloud tools along our way. Like we've always had relatively small teams working on these systems. Maybe, 15-20% of like all software development effort at AMP over the last 9-10 years has gone into cloud integrations in one form or another. I do think the ecosystem for this has been getting better, but certainly I think we were early to large scale with kind of ROS systems like this. So a lot of the companies that have popped up since weren't in good working order when AMP would have needed to adopt their technology. So a lot of them we found after we'd already built custom systems, and then moving off of our custom system to whatever paid offering they have has been tough. And also a lot of the systems that we've talked to that are offering, solutions to this in the cloud robotics space don't make it easy to integrate the system how we would want to integrate the system, where, we might need special control over things. We don't want to be configuring stuff in their configuration GUI. We have an enormous amount of cloud infrastructure that we maintain across like our ML pipelines and everything that's all done with good infrastructure as code kind of setups that we don't want to add glommed on random people's other cloud things to our cloud. We want it in our cloud, managed in our Kubernetes instances, managed in the way that we manage it, where it plugs in nicely. And a lot of them are trying to give you, walled gardens over here that make bridging in difficult. So talking about, where AMP is heading and what AMP's been doing, we are still on ROS 1 as our kind of main back code base, but we're midway through a migration off of ROS 1. We actually aren't migrating to ROS 2. We looked at ROS 2 migration stories a lot, and we're pretty dissatisfied with what we saw. And really, AMP has been using less and less out of the ROS ecosystem over time. Like as we're getting to, a 10-year established code base, we really like the architecture of ROS with, schemas and IPCs between nodes. But like we haven't been using an off-the-shelf node that someone has written for a long time at this point. Where we're migrating to is just using Xeno directly. Like we really like Xeno, and we're really glad to see ROS 2 switching to Xeno now, but we can just have a nice IPC layer over Xeno directly. A lot of this has been enabled by us investing in Rust, and specifically there's a library that we maintain, ROSlib_Rust, which is a abstract Rust interface that lets you talk ROS 1 or ROS 2 or ROSBridge on the back end for it. That's what a lot of our kind of client code is. And we are heavily migrating code to Rust pretty quickly right now. So, originally heavily C++ code base. The facility control software that we ended up writing on top of all of the robots, we wrote from scratch in Rust and had great success with that, and really think that it improves developer velocity and tooling substantially. So trying to do that there. The other thing that we've been doing a lot is, our original paradigm for these systems was fat systems at the edge, because we were deploying them in customer sites and we needed all the bells and whistles on that system at that site to make it highly functional and highly effective. But now that we're moving predominantly into the sort of facility paradigm, we're trying to strip a lot of features out of the individual, robots and move it up to that facility control layer. And then if we can, move it up to the cloud. We do think that there's a strong philosophy that folks should adopt of code is cheapest to write in the cloud and gets progressively more and more expensive to build and maintain the further you get to the edge. So things like having configuration history and configuration files. Why should the robot have it? The facility control system should hand them their configuration when they start up. And why are the metric files coming off the robots? The metrics should go to the facility controller, and the facility controller can go up. And we call our facility controller often like the fog level. It's the low level cloud. So doing a lot of stuff in that area. And then lastly, I talk to these companies and startups that are trying to build these tools for this environment. I'm here talking to you guys today, mainly because I have trauma from having had to build so much of this custom over the years. And we really want solutions to manifest from the community and from the market that solve some of these problems for us. The major problems that I've talked to a lot of people about, like what makes developing robots today hard, while ROS provides this great ecosystem of pluggable components, I think their story on how you actually package those and deploy ROS versions of your code to a system is kind of non-existent. Everybody kind of just says Docker and waves their hands and walks away. So how do you make releases? How do you build those releases into images? How do you ship them to sites? How do you do rollbacks? How do you do versioning? None of that is kind of built into the ecosystem in a good way. I think configuration management, mentioned it a couple times now, but also defining your configuration files, having schemas for them, tracking history of them over time, having update logic, watching when configuration changes. ROS has solutions to these that are great for prototyping and then get really hard when you're dealing with hundreds of robots deployed around the world on 15 different versions of software, all trying to talk to cloud tooling, all with slightly different schema formats. There's a lot of issues in there. Bag files are really nice. They obviously have a lot of problems. There aren't a lot of great tools to record bag files with these topic priorities, with these bandwidth limitations, store and forward, upload, index. I'm seeing many of these things get built out better, but it's tough. And I will say, I've heard great things about the new MCAP file format, and we were just late to the party on kind of being able to adopt that easily. And then the last thing that I'll say is there are amazing cloud resources. We are a house of Google and use Google primarily as our cloud, but when people are building out these cloud widgets, they often show us these very, sexy looking tools that then you get to the meat and potatoes of how do we stand one of those up? How do we integrate them with our infrastructure? How do we keep them reliable? How do we do staging deployments of them to test against and all of those things? And the integration stories get really rough on a lot of those tools. So I need a lot more off-the-shelf recipes of, okay, you have this great thing that will help me in the cloud. How do I set it up flexibly across multiple clouds and connect into things nicely and deal with VPNs and security and OPSEC tunnels? I think the broader open source robotics ecosystem takes everyone kind of a little bit down that road, and it just assumes an enormous amount of professional knowledge and capacity as people actually try to get systems rolling out in production. That's it. That's the end of my prepared content. And sorry, I just word vomited at you in a barrage there, but that's my intro, and I'm really happy to talk about any and all details of that going on.
This was awesome. Thank you.
I feel like this is exactly the kind of stuff that we wanted to hear about from start to finish. This is great.
Yeah, I mean, I don't know how much context we set for this, but because of the sort of the tenor of your slides, I'll repeat it. One thing that we try to do here in the group is identify. We polled the community and we asked, which are the guides that you wish you had? What sort of how-to guides would you like to see? On the topic of cloud robotics, and we broke it down a little bit, log ingest, observability, and we have some other ones. And right now, obviously, we're in the log ingest and observability. And I think your slides mentioned a lot of great open questions, right, that deserve further. And, you know, partially the answer that we might give to the community is, yes, that is still an open answer. Stop looking. Most people build their own stuff, and here are the reasons why. And this is very useful because, you know, it triggers people like me to start thinking about it. What could we do to address that, open source or otherwise? And for practitioners, it's great guidance. So this is very, very, very useful for us. Thank you.
Go ahead.
I do have some questions, but I don't want to monopolize it because I'll never stop when I start. So please, somebody else get started.
I had a couple that I imagine will be fairly quick to answer. So I'll jump in ahead of Christian and then hand over to Giovanni as well if he's got any ready. First, I thought a couple of really important things. We've had 3 people come to talk to us about their cloud tools, and we're going to be doing. We're going to have another company next session. No one to date has mentioned Parquet format, which I am a bit surprised by because I've heard of Parquet in the context of being able to search through it in cloud tools. So I'm quite surprised this is the first time it's come up. That's not a question. This is also not a question. Don't put metrics in logs. It's just another important thing to point out. So thank you for both of those.
Yeah, I honestly, like, I've talked to a lot of developers that seem to have, you know, conflicted opinions about this. Like, a lot of people swear by this idea of like structured logging and the fact that you need to put a lot of data in your log, and your log needs to be in a JSON format. You need to egress your log, and then you need to be able to have all of this data on it. And we've really taken the philosophy, like, we're building ROS microservices, like in that vein. Instead, if your node has state that you care to observe, you need to put that state on a topic and have the ability to egress that topic as data instead of as through the side chain of a log format out. And I've seen a lot of people screw that up and trip on it. So I absolutely will hammer that advice home of if you're going to do logging, you need to have a very clear thesis on why you're doing logging and what purpose the logs do serve and what purpose the logs don't serve. And so we have to be like strongly, people should not be putting data in logs. We should not be going to log files to like create a graph over time. Anything that is like good numeric structured data that we care about, get it out as a metric so that there is a way to build something like a Grafana dashboard over that thing or do real statistics on it without having to parse it from a log file. Like, that's crazy.
Yeah, you should be able to do Grafana on it without parsing it. That's good advice. Data priorities. I was wondering if you could give us a kind of idea of what things you consider to be very high priority data and things you consider low priority data.
Yeah, so at least for us, we had a top tier SLA of like, here is the data that we are guaranteeing to customers. So whatever is highest priority, that starts at that layer. Second tier of data is the data that we always expect to have off of every system, which is just our like baseline metrics for tracking the health of that system. You can imagine that would include like picking data for one of the picking robots, includes like temperature data, things that we care about would tell us, you know, fundamental like hardware failure properties on it. Third tier of data then gets into like optional debug observability data, which might be like, hey, it's nice if we can collect ML training data. And so like if there is bandwidth to upload, you know, some frames, that's a helpful thing, but is less important. A major like second axis that we struggled with this on a lot is, okay, within all of those tiers, then there is a temporal element of, okay, the robot's been offline for 2 weeks because the customer's internet went down because somebody crashed a truck into a pole. They get internet back. Do you upload the oldest data first, or do you upload the newest data first amongst all of those categories? And we flip-flopped on that many times in the design of, do customers care about getting the historic data because they're going to make their like end of month closeout and they need that data, or is the customer looking at the system right now and they care about the data that comes urgently? And frankly, I'm still not sure we have an actual answer there, but at some point in the code, mechanistically, you have to make a choice about, you know, temporal prioritization. And obviously like random's the worst choice because nobody can expect anything. So fill from one end to the other end. I will say it's a very hard thing to represent in a lot of the cloud tooling, this idea that we either are waiting on data for a particular zone of time, like the data is missing but will eventually be filled in, versus the idea that no, the data for that time region doesn't exist and isn't coming. And having these ideas of like, is the report for this month that we're looking at these systems as complete as it's ever going to be, or is it still just waiting for data to get closed out? And so we've been trying to, come up with good metrics in the cloud to ensure when a robot has closed out a time window where like all data from this time that's ever going to make it to the cloud has made it to the cloud or not. And that's just like a weird concept I didn't expect to have to tiptoe around.
Did you look into? I mean, probably you have. Did you look into checksums for that? Right, where you basically checksum the data, like almost like an recursive LL, right? Like these are all of the files, these are all of the sizes that you can expect. This is before you start uploading, right? Have you explored something like that?
Yeah, honestly, this is very easy to build because at least the robot knows what the contents are going to be when it starts the upload for a time window. The case that this is specifically guarding around is like we have a fundamental hard drive limit, and if the robot is offline for too long and then starts deleting data, like we do have data loss. Data loss is inevitable, and so knowing when we actually lost the data and not when the data is pending, we ended up needing to implement some level of tracking for
that. That was really interesting. And my follow-up question of which is better, you've already answered of we don't know. Sadly.
Configurable is better.
Yeah, that's a good answer. And then I think my other question is, can you talk a little more about the kind of tools, like off the shelf tools that you've looked at? For example, we've had talks from KubeEdge for helping to deploy from a Kubernetes cluster to a bunch of robots. Is that something you looked into? What other tools did you look into? What kind of problems put you off using them?
Yeah, and it's hard to answer that question because there's probably 20 or 30 tools total across all the different solution spaces. If we kind of go maybe solution space by solution space, there are a number of offerings out there for the idea of managing your fleet, air quotes, where like these companies seem to be primarily selling to like an operations group within a company of like, here's a dashboard you need to have for what software version things are on, how updates are going to be rolled out, how to do, beta tests of things. None of those tools were available, or we could find them at the time that we were building this stuff. So we ended up with a custom solution in that space. Since then, I've looked at several of them. The names aren't springing immediately to mind. That's something that today, if I was going to build another company, I would not build deployment tooling from scratch because it looks like there are good offerings in that. And I know like Formant and Freedom are like adding that as modules into their systems. Like I think a lot of people start offering some kind of cloud option in one of these areas and then kind of start tacking on more and more capabilities to address different portions of this. Another area to talk about in here is actually just the managing a connection to the robots. There's like half a dozen industrial vendors that offer in one form or another some like VPN box you can buy, some USB key you can have, something that will give you VPN secure remote connections. There are so many of those systems. We started with running our own VPN server and setting up OpenVPN ourselves in literally a closet at our headquarters, and then eventually moved to paying someone to manage that VPN setup for us in like a cloud setup, and literally just outsourced that. But it is just manually set up VPNs, and it's a pain, and you deal with a lot of weird low-level debugging about why the Ubuntu service for the VPN didn't start up, or if it failed, didn't restart correctly. That's annoying. So certainly just like getting a connection to your robot is hard, and we certainly cared a lot about. I think people have different opinions about whether your robot should have one secure connection that you then funnel all data through, or whether it should be making multiple secure connections out to different people. Certainly working with the industrial partners that we have, they massively prefer that one pipe. They want to open one port for our robot and one hole in their firewall, and we have to like give that in contract arguments to them when they're installing this in their facility. And so whatever, like if your tool comes to me with a, oh, and we can securely upload your metrics for you to whatever Google thing, we might not be able to use that because we have to start with it going through our VPN type and us being able to wrap that in a secure controlled connection around whatever you're going to be doing. And yeah. I can keep going down more tools, but there's, yeah.
No, please. So at CRWG, we went through that, right? So at CRWG, we had 100 robots. They were on our customer Wi-Fi's, and customer Wi-Fi's have all of the problems that you mentioned. Sometimes they don't know how to configure it. Sometimes their firewall is super restrictive. And we did the same thing. We had an open VPN server running on every robot, or a client, sorry, not a server. Yeah. And that was very unreliable. And so over time, over the years, we had a very key insight that I think is that I wanted to test with you, and that is that robots should not be servers, they should be clients. And what that means is that the only connections that the robot will ever create are over HTTPS, and they are outbound. And then if you want to go inbound, you do that over the connection that was established by the robot. So basically, the robot establishes an HTTPS connection to the cloud, and then if you want to get back into it, you go through that, right? So there's ways to do that over WebRTC with terminals, so you get full access. It's something that I highly recommend if you haven't gotten to that yet. It makes, because the nice thing about HTTPS is it's the last protocol that your customer will block. And so that was actually the reason why we had to look into that. Some of our customers weren't even allowing us to open a VPN connection.
Yeah, and I'll say this. I think that is a great idea and a great concept. It was not an option for us. And one of the reasons it wasn't an option for us is like, we are technology integrators. We're not in control of everything that we have in our cabinets. And so we're buying off-the-shelf industrial arms that are coming with their own control computers, that their control computers are pretty damn closed off by those manufacturers, and they don't have the best cloud thing for them. So when we need to be able to debug the robot behind our computer in the system, the only way to do that was with a VPN connection over it and their stupid GUI tool that comes from the robot manufacturer on it. And so being able to have like a full VPN tunnel to at least get to that lower level systems was a requirement at that time in the day that we were doing it, because a lot of these, industrial manufacturers aren't used to those kinds of setups. But
yeah, we should take this offline. There's ways to do it, right? Because really what you need is a shell into the robot and the ability to share windows. And for window sharing, screen shares over WebRTC, similar to what people use for teleconferencing, is actually insanely efficient, right? So, but that takes us a little too deep here. But it's a lovely topic. Everybody in robotics knows the problems about networking.
Yes,
and you definitely felt the pain.
Yeah.
That's all my questions for now. Thank you. Really interesting answers. So. Giovanni,
I will let Chris go. I just have one comment, Carter. I really like your talk. I reiterate, this is really the kind of thing we wanted to listen. So experience from the ground. And there's also something I want to highlight that you said, which I think it's also a big truth. You said code is cheaper to write for the cloud than for the robots, and somehow. I think this is also some of the things that we are saying in this group are also true for other things about cloud robotics. Somehow, a lot of solutions that have been developed by cloud developers, the people that are developing for the cloud, are much more mature than the ones we see for robotics. Maybe because there's the size of the developer community is completely different. Maybe because they deploy for world size, global size services and these sort of things. But somehow I was thinking when you were saying, when you had your slide, what do we want? Maybe I think I'm also listening to this group or participating in this group, because I think maybe we should actually look even more a bit into cloud, how they solve things in the cloud, and try to port it to robotics. There's been a lot of resistance, but I think now people are more and more realizing these sort of problems.
Yeah, and I'll say, we have 4 layers in our stack effectively. We have, a hardware layer that is either the robot controller or, custom embedded code that is running at the 1000 hertz rate and on a microcontroller, non-Linux environment, super time sensitive. You then get to the kind of vision computer on top of that that's running the neural network that needs NVIDIA, that is ROS, that is doing a bunch of stuff. You stack the facility controller on top of that. You stack the cloud on top of the facility controller. And so anytime someone comes with me with a feature and says, here's the feature, where do we put it? It becomes a major question. And we deal with the classic problems that companies have of like, the cloud developers develop in completely different tools and languages than the facility controllers developers, than the ROS developers, than the embedded developers do. And a major thing that I have been looking at is trying to unify that development stack and unify that experience across our internal teams, so that the tool gets built in the right language, in the right place, by the right people, not because this team had bandwidth this quarter and that team didn't. Like, you go around and look at our architecture and look at like, well, why is this wart over here and why is this wart over there? And it's often, the needs must problem of, well, we had an available Python developer this quarter and we didn't have an available C++ developer. And I've said before, like, I'm very excited about Rust. I will continue to double down on that because we're finding Rust is the C2 cloud unified language that lets us write the code on the microcontroller, lets us write the cloud function in the cloud, lets us write the facility controller, and has good performance and good abstraction capabilities kind of across that depth. We still love Python. Like, we'll never get machine learning off of Python, but we're stopping having to jump so many layers of like needing really specialized embedded C knowledge for the microcontrollers and then all the C++ knowledge for the raw stuff. I can at least eliminate some of the team and design breadth across it. But it was a major learning experience for me along the way to discover that the only thing that matters in where the code should run is latency. It is the latency and frequency you need to run it at. If it can run at lower latency, at lower frequency, higher latency, move it as far up that pyramid as you can possibly get it. And that's advice I would double down on any day to anyone.
Thank you.
Perhaps on that note, I don't know, Giovanni, whether you have other questions, so this will be quick. So the typical reason why you don't want to run on the cloud, and I think that's where you started too, is that for operational purposes, you cannot rely on it. Right? You said yourself you might be offline. And the first question is, of course, safety. Safety cannot rely on the cloud. But even operations, like, you don't want your robots to be unproductive, like twiddling their thumbs, so to speak, if your internet isn't working. How do you deal with that?
Yeah, so one of the regular questions that I am asked at our company is, does this feature impact facility operations in such a way that it falls into like the internet denied zone of it? The other thing is, like, now that we are controlling our own facilities and we are building, factory level controls, and you talk about like a $15 million something facility, the cost of having like doubly redundant internet connections at the facility level is so cheap compared to the software development time of solving that problem. And like, even back in the day, ask me what is the hardware cost and like OpEx cost of adding another cell modem or adding a redundant backup communication mechanism. It's a hell of a lot cheaper than engineering your entire stack around dealing with some of those problems. That being said, we view the latency, at our factory control level, like, call it 1 hertz. 1 second latency is a reasonable intervention frequency for the facility controller. The internet, we usually approximate that as like 5 minutes. Like, yes, absolutely, it can do better than that on average, but from a design standpoint, the internet can go out, the facility can run for 5 minutes with no problems any day. That's pretty normal for us, and we do a lot of local caching. So like a good example of like a workflow where we make this distinction is, say, like authoring a new whole facility configuration where you need to decide what everything in the facility is going to be decided to do. You can only author those in the cloud. So if you want to design a new facility configuration, that's a cloud UI that you're going to. When you deploy those, you then put a local copy of that thing that you created in the facility, and now the facility can switch which configurations it has as a local non-cloud action. And that's a really good design to give you the maximum flexibility in the authoring tool, but still the flexibility you need at the facility level. So like someone tries new deployment, internet connection goes out, they can still switch to the old configuration. You're not stuck in things. And so like you asked, how do we deal with it? I think careful design and careful like user story observation. But maybe the advice I would give someone in here is I see a lot of bad design done in robotics out of fear, where people are like fearful that oh my God, this 1 in a million case might happen. And they use that fear to justify shoving things down the stack. Like, well, maybe this might be a problem, so we need to put it at the lower level thing. And we strongly emphasize the like, do the cheapest, fastest thing, see how it breaks, and then iterate from that. Let it break before you shove it down the layer. And like, we often will regularly build something in the cloud, wait to see if that is a problem that it is in the cloud. And if so, it's not that hard to then move it down the layers of the stack. I think people strongly overestimate the cost of moving something down the stack once it's already built, and they strongly overestimate how painful it is when that thing breaks. Like if it's safety, obviously that's not one that you gamble with, but you can, you know, wait until it's a little painful on a lot of things and then move them later.
I think that makes a lot of sense. And I think especially because you've realized that isomorphic code is a real benefit, meaning like using the same language in every layer of your stack. That was the big insight with JavaScript, right? When Node.js came out, people were like, are you nuts writing a server-side JavaScript thing? And then they started working with it and they realized, man, I can take a function and I can just literally copy and paste it from my client to my server, because I realized it needs to run on the client, not on the server, or vice versa. And no cost at all, right? And that works particularly well, of course, if your data architecture is you follow really the MVC framework, where your data is your data. You don't mix instruction with data. And now, well, you just synchronize your data. We are always acting on the same world model in the cloud and in the facility. So I can literally just take that function, put it from the cloud to the facility controller, and run it at higher, like lower latency, right? So I think that makes a lot of sense. I guess the other thing that you have in benefit is that where robotics companies usually struggle with connectivity is that the robots move. Yours don't move. So once you've identified, we did that at Sevier, we did a site survey where somebody would literally walk through the hotel with 2 cell phones, a Verizon one and an AT&T one, and they would measure, you know, which one has better coverage, and that would be the provider that we would use for that facility. And I guess you can do that too, right? Like you can actually test, you know, how good is your network? Because one thing that, you know, everything being said about cellular networks and how flaky they can be, in one location they're usually pretty stable. Like there's not a lot of variety, so there's not a lot of variance, so you can test it, and then if it works, it works, and if it doesn't, well, then you can figure out a different provider, Starlink, something, right?
I was going to say Starlink is a real game changer here in the ability to just add a redundant connection that is geographically diverse, that is separately powered. So like, you know, even if the pole crashes and it takes down, you know, Comcast in your area, often that can also take down Verizon in your area if the like wrong pole goes out. So Starlink just provides, even if it's a more expensive or problematic in other ways connection, a really good redundant connection for a lot of these options. I will say we still do that same survey. So like if you're in one of our facilities walking around, you're on a laptop or a tablet connected to the Wi-Fi talking to the systems, and like OSHA requires us to verify the Wi-Fi coverage in the facility and still have that going. So like we still deal with those connection planes, but they're not on the robots, they're on client connections to the robots. And so like, you still never trust the network, but yeah, I know those pains, but have not had them as bad as a lot of people deal with it.
Very cool. Question about alerting. So you mentioned logs are not automatically uploaded, only metrics are. I'm assuming you have some sort of automatic alerting. Is that I'm assuming that is built on your metrics, or can you say a little bit more about that?
Yeah, 2 tiers. So I think a critical design aspect of any robotic system is that robotic system must have some kind of master health that it is able to summarize and report locally. And so, you know, in our facility control maps, you're going to see a bubble representing each system. That bubble will be red, yellow, green. That is a local determination made by that system about its own health. And so there is some base level of alerting that I think must be inherent to every system, but also you don't want that alerting to cover everything in all of the cases. If the alert can be a thing that is on a lower frequency, done at a different time, put that alert in the cloud. So we really do have a heavy mix of, there is a fundamental model of system health that must be determined at the edge that like each system is individually responsible for. And then there's this second tier of a bunch of metrics get uploaded to the cloud. There are things that look at those metrics in the cloud. Those trigger red bubbles and flashes and dashboards. The biggest thing that I would give as advice to people doing alerting in this space is very, very carefully understanding your audience and what the reaction is. Like a thing that was very hard for us to learn. If there is a map for the facility at the local site and a bubble turns red on it, unless the person at that facility can do something to make that bubble turn green, it's not helpful. And so if the problem is a configuration problem, or the problem is some system that doesn't require hitting something with a hammer, that bubble should turn red at HQ, not necessarily on site. And so hyper focused on who is the audience of the alert, what is the triage of the alert. Like, don't build alerts for the sake of having alerts. Build alerts with a plan that when this alert goes off, here's the action that will be taken, that will close that alert, that will turn it off. Like, the back half of that is more important than the front half. And I think people spend way too much time thinking about, how am I going to get the data? How am I going to analyze it? What's the like function that's going to turn the bubble red or not? And not enough on the, okay, the alert's gone off. What does that mean to actually make things better? Because all the observability in the world doesn't matter if you can't do anything about what you observe.
Yeah, for sure. And on that note, how do you, so you mentioned you use ROSBridge. Do you also use ROSBridge for syncing data to the cloud? Or what is that architecture like?
Everything that is a metric is effectively a GCS file upload. Like, we upload a file to a bucket as the way that data gets off the systems. Those used to be ROSBag files. Those are now Parquet files. And then that bucket upload triggers all the things in the cloud to go and look at it, snoop those, and index those buckets.
But how often do you do that? That's not very useful for real-time stuff, right?
Yeah, depending on the system, maybe once every 10 seconds, maybe once a minute on other systems. And so like it's not hard to take 30 or 40 ROS topics, bag them into a file, compress that file to get all the storage efficiencies of compression, and then upload with a slight delay. And you think about things that either need a 10-second or 1 minute latency. That's not hard. And this is where I'm talking about that like tool that is one deciding what goes into those bag files, and when those files get uploaded can prioritize both the contents of and which file gets uploaded when. There's a lot of bookkeeping you can do there.
So don't you then upload a lot of duplicate data? Because let's just take a simple example, the temperature of a system, right? It may not change in 10 seconds. It may not change in the next 10 seconds either, but you keep bundling it up and uploading it. Isn't it more efficient? So one of the design principles that we did with Transitive was we wanted to avoid the duplicate upload. So we wanted to actually data sync. The issue with ROS and a lot of these pub subsystems is it's really just message passing. And in ROS, we all know that it will happily publish the battery level 100 times a second, even if it doesn't change. And that's obviously completely inappropriate when you're uploading to the cloud, because you only want to upload the change, but you want to do that reliably. So the trick is, yeah, of course, it's easy to wait until there's a change and only upload it then, but then you need to deal with the fact that you might be missing a message. So some of these problems we had to solve.
I think solving that is great if your cost of upload is expensive or your cloud cost is that high. Ours never were that expensive or that high. And so I do like build the simpler system if you can. We redundantly upload a ton of stuff. And I feel happy about redundantly uploading it because it gives me a lot of confidence that we did know the value of that parameter at that time and didn't like miss a delta or something with that. Like if you're going to do that kind of syncing, there's now a whole like second tier of reliability and complexity you have to think about. Our like upload costs are cheap, I think, compared to a lot of people.
Probably the format they are using is already compressing at the source, so that cost is very minor.
It depends on what you upload, right? Like if you want to upload point clouds or images or something like that, but that's where you get into specialty format compressions anyways. The other one that you mentioned is something that I usually describe as cross-device dependency management, meaning that different fleets, different deployments may run different versions, and they all need to talk to one cloud. And so then I'm assuming you're going with the sort of classical approach where the cloud is the one that has to be able to deal with legacy formats and be backward compatible. Is that how you do it?
Yes, I would say there's tiers in all of this, and I think this is something that I don't have a standard formula for. I think is always, cross-team negotiate appropriately. And so I mentioned our robots have a RESTful API on them for, certain interactions with them. The robotics team that maintains that API is very careful about versioning that API and releasing new versions and allowing migration to it. And that is their air quotes, hard interface with the rest of the company. And I think it's very important to define, where your hard and soft interfaces are. Like that is a versioned interface that the robotics team provides to the rest of the company. The metrics file format is not hard in that sense. The metrics file format, every robot uploads in its metrics format. We rely on the thing in the cloud to be generic over the formats. And so picking, who is strict in what areas and where, I think is important. And I don't think there's a universal decision there. I think you have to decide a lot on the flows and how the tools are going to evolve.
So there's a trick that we adopted from gRPC, which is to version your data, meaning that the data package itself states the version of its own schema in every message, right? So we use that in transitive. That we're built on MQTT, so our topics have a version string in it, so that when the cloud receives the data, it knows, oh, this client is speaking to me in version 1.1.2, and the other one is talking to me in version 1.1.3, and then we have like the cloud counterpart. That way, you're always safe to speak the same language until you get to an aggregation point, right? Usually then the aggregations are the hard part, but at least you know what you need to aggregate, similar to migrations. Have you like looked into anything like that?
We have mixed versions of this across it. So like those REST endpoints are versioned, version 1, version 2. That happens on those. We are like standard message interchange. Like if we're doing robotics to cloud kind of stuff, it's always JSON, and JSON schema, while imperfect, is the schema language that we found to be most universal across all of our tools 8 years ago, and so is regularly used. A huge number of our JSON schema documents include a version tag in them, and the ones that we care about getting right are versioned in that way. The other thing that we do, though, is like JSON schema makes it pretty easy to make a backwards compatible schema and check that it is. And so we do a lot of adding new optional fields to not make it a breaking change and being careful about that. I would say we don't have a universal solution is a constant problem and has to be negotiated at each place and each interval. If I could go back and snap fingers about like tech debt things, I would have wished to have fixed at AMP. It is a better fundamental data schema design from the beginning about how all these messages were going to be passed. Really, it started with cloud team doing cloud stuff, ROS team doing ROS stuff, and then eventually lots of work to negotiate out JSON as the data format, JSON as the string, versioning of all of that. None of that's particularly built off the shelf. And like if it had been gRPC the whole time, might have helped a huge amount.
Mm-hmm. And then before we close, maybe really quickly, your remote UI, what are sort of the features that you have there, both, I guess, for your operators as well as for the client in particular? I mean, personally, I'm, of course, mostly interested in whether it includes things like video streaming. But yeah, can you say a little more about that?
Yeah, it does provide video streaming. It was built originally as the UI that like our customers are going to walk up to on a local touch screen and start like pressing the buttons on it. So it provides the UI workflows for calibrating the system. It provides a lot of developer utilities because it's also what developers use when they're like sitting at their local system interacting with it. So we can start and stop nodes from it. We can change log levels of nodes. We can view logs. We can view all kinds of metrics. We can view some amount of historic data. Lots of status information rolls up, alerts, alert histories, all of the things that you would typically expect for like an industrial HMI on a piece of equipment are all built in there. The video streaming has, of course, been pain in the ass the whole time. Web video server, hate you, but needed.
Yeah, we should. I don't know whether you remember, we touched base on that a few years ago. Maybe we could resume that because but I'll send you a blog post why WebRTC is great.
Yeah, and I've heard amazing things. Now the paradigm has changed so much that now that we've moved into our own facilities, like the reality now is our facilities have a fat upload pipe, and we don't have to encounter a workflow where 40 people are looking at 40 robots in the facility at one time. Like one person can get a very rich experience, and the overall facility has plenty of bandwidth for that. So a lot of those problems just disappeared as we moved into the facility paradigm in ways that still aren't addressed. But
one other thing that you said that I found very interesting for this group is that you said 15% of the effort in the last 10 years for your company went into the cloud and robots integration. That's a huge thing, and that speaks massively in favor of somehow responding to your search for solutions, open source solutions that are there. Would you say that the new technologies that are there, you mentioned Foxglove, Formant, Freedom, would you say that now it would cost much less, or could you make an estimate how much you think it would cost today to do the same thing you did?
I really don't know. And like the problem I have is I want to be very honest about what experience I've had. I've had the experience of building the tools custom. And, you know, along the ways, many times we looked at the build versus buy decision, and the buy decision wasn't ready enough or didn't fit our use case enough. But every year it seems to get closer and those companies seem further along. I've not gone through the experience of actually adopting those. Like I absolutely expect to talk to a company that's like, oh yeah, well, we adopted this thing off the shelf and it worked great for 2 years. Then we outgrew it. And then the cost of migrating off of it was so high that we ended up back on the custom thing and it cost more overall at the end of the day. I don't know if that's true or not right now. I am very optimistic of it. And I want to be very careful when I consult with people who are considering starting a company and building these things. We built custom. I have no idea if that was the right decision for us at the time. I have no idea if it's the right decision today, because you just don't get the chances to see 5-year tech arcs and A/B test the 5-year tech arc. It's really hard. My strong assumption is that the tooling is getting much better, and that more of the things off the shelf should be used today than was true as AMP was building along the way. It's an assumption. It's not a tested hypothesis. So
amazing.
Yeah, there's also companies like us that try to exactly break the buy versus make dilemma by going a middle ground. We're running out of time. Mike is eager to wrap it up before we get kicked out.
Yeah, that's the thing. Your call ends in under a minute. I don't want us to just be cut off. Thank you so much for coming and joining us, Carter, and for your experience. It really was fascinating. I'm sure we could write multiple posts about it just to try and share the knowledge a bit. Next week we have Insion coming to join us. They're another company that are providing logging and observability solutions. So we can look forward to hearing from them. I'd still like to get another person from a company like AMP to talk about their experience, and we can see how it matches up. I haven't had much luck on that front, so that's still work in progress. So that's it, I think, for this week. See you next session. Thanks, everyone. Bye for now.
Bye.